This is the powder pump. It's a sample introduction device for ICP spectrometers. Here we've got the control panel. On the top left you see the start, stop and reverse buttons. Pretty self-explanatory. The feed rate adjusts the feed of material into the ICP. A zero rate is very slow, and the highest practical speed would be 40 or 50%. On the lower left you find the sample timer. This is useful if you've got a diode array spectrometer. You would set the sampling time down to perhaps 10 seconds or 20 seconds. This prevents your diode array from overloading because of the large amount of signal that you're getting from the torch with this accessory. The sample gas flow is a pressure flow control that directly affects how the powder is picked up by the pickup needle. The mixed gas flow is mainly a purge flow that keeps the line to the ICP full of argon and doesn't admit air into the system. The sample gas flow pressure should be set to somewhere between 1 and 10 pounds per square inch. It's safer to start with a higher number and work your way down than it is to start with a lower number and risk clogging. The mixed gas flow can be left somewhere in the middle of its adjustment range. A sample vial like this is packed with powder, and then it's put into the powder pump. In this position here. Then you press the start button, and this carriage moves up to the ready position. Once it's in the ready position, you'll see the vial start to spin. It's mainly a drilling action with wearing away by the gas flow that allows the material to go through. Once it's reached the ready position, the vial starts to spin and the powder is drilled away and sprayed up through the central tube here. You don't see the connection tube to the torch yet. The feed rate is set on this dial. If we turn it higher, it'll move faster. If we turn it down to 0, 0 is probably the lowest usable rate, which will give you about 6 minutes of sample. You can press stop and reverse at any time if your sampling is finished. Then the old sample is removed and a new one can be introduced, and the cycle starts again. Connection of the machine can be relatively simple. At the back we have a power cord similar to that used on computers with an on-off switch for electrical or 115 volt power. And on the other side we have a gas connection which can be made by pushing in a 1/4 inch polyethylene or nylon tube into the back. To remove the gas tube, you push the collet and pull the tube out. The third connection is the connection to the torch, which is made at the top of the block shown here. You insert the tube over the pickup needle and tighten up the chromatography fitting or nut. Finger tight plus about 1/8 of a turn. If you tighten it any more, you may cut off the gas flow here. And your final part is the removable center tube for the torch, which is shown lying on top there. So you have about a 3-foot thin gas line to the torch. The adapter for the thermo Gerald Ash ceramic body torch is assembled like this. You put the fat O-ring over the brass tubing, and this plate is tightened using these spacers underneath the ceramic body of the torch, which would go right here. This squeezes onto the torch body the same way that the spray chamber does with thermo. So this is a simple adapter. And here you see the tool kit for the powder pump. These wrenches are not supplied, but this 1/4-inch wrench is used to attach the center or the transfer tube from the top block to the transfer tube to the torch. This wrench is used along with this modified 1/4-inch wrench to adjust the pickup needle or remove the pickup needle. I'll show you that later. These 3 pin vices have different things in their grasp. This one has a 20 thou wire, this one has a 1mm drill, and this one has a 1mm wire in the middle of it. The drill is used in case you have material stuck in a vial that you'd like to remove. You simply put it in the center and drill out the powder to remove it. This allows you to reuse the vials. This one was packed in rather solidly. So. It's also possible to use this thin wire to do the same thing and take most of the material out. Now to fill a vial, we take this funnel, which is just a machined piece of Delrin, which fits snugly over the top. And then we add into the funnel, we add a bit of powder, in this case kitchen flour. And to put the material inside the tube, you'll use this 1mm wire and plunge it through to continue to get material in there. Generally, you'll have to, depending on your powder, you'll have to tap it in and tamp the air out. I'm only pushing in here hard enough to remove the air from the sample. If you don't do this, you'll tend to get clogged needles and uneven powder flow. I'm going to let you see the whole deal just to see how inconvenient it is. But you can contrast this with how long your digestions take and perhaps how long it takes to run the sample. Now this vial is stuffed full. Now we come to the part about what to do when things go wrong. Typically, the biggest problem with this machine is when the needle inside this chamber clogs because your pressure set on the gas flow is too low and it doesn't take the material up. Another problem can be when you haven't compacted the material properly inside the vial and then it flows up in clumps instead of being worn away by the needle, and it will jam the pickup part of the needle. So first I'll take the sample vial out and I'll show you inside this chamber the needle that we have here. Often the pickup tip is the part that's clogged. To unclog the needle, you'll have to take off the center tube here, and I found that this can be done with the torch still running, even though it supposedly admits air. Take the small diameter wire in the pin vise and put it into the center of the pickup needle, which is visible at the top here. Shove it down until it shows up at the bottom of the needle here. This will unclog your needle almost all of the time. If in fact the needle is clogged and this wire cannot clean it out, you'll have to remove the needle and replace it. To do that, you'll want to use this tool, which is just a 1/4 inch socket with the sides flattened so you can get the wrench on it. Put that up here, put it on the nut, and the nut is similar, or the same one actually, as this Valco nut here. You take it and you basically unscrew it to remove it. So you unscrew this, that releases the plastic ferrule inside, and you can pull this needle out and replace it with another one. To replace the chamber, you simply screw it back in here. An O-ring seal seals against the face, and it only requires about 2 or 3 fingers to tighten it. Also inside here, you have you can see the other O-ring seal, and you have also a Teflon seal that that seals on the vial itself. This seal is replaceable in case it wears out, as well as the O-ring is too. And again, 1/8 of a turn from tight.
Okay, so, are you going to tape me doing
Yeah,
everything? Or?
no, I'm not going to tape you.
Okay.
I'll just tape the torch.
Okay,
and
so you're
then
going
all
to start together again?
that. Yeah, sure. You want me to start it?
Oh, I can push it, and then when I hear the noise, I start.
Yeah.
Now it's starting?
Yeah, it's there.
Oh, there it is. reverse it?
Yeah, sure. Upper. Well, that always looks better. So do you know what mineral this is?
Oh, yeah. This is a jasperoid.
Jasperoid?
And the other one, the first one I did was cyanide.
Cyanide.
That's the official one.
Okay.
And the blue, that's just pretty high iron.
Iron, you think?
This has got 33.8%.
You seem to have nothing going through there.
Is it foggy, you think?
Seems like it. So we're running the jasperite sample again. See if it clogs again. Sounds like you got it clogged again. What color is the iron here?
Blue.
Oh, the blue, yeah. I pretty well guarantee your clock still has something.
Sodium.
Yeah, you know, really, what are the metal?
Is that some of my stuff coming through?
No. I see, because I cleaned it out.
Oh.
I had some of the jasperite in it, but now I just have what looks like very clean flour in it. So this is Canadian wheat flour.
Copper.
Copper is an essential. It should be zinc, right?
Yeah, this is it.
How about cadmium?
Yeah, I feel like that's cadmium.
See, cadmium is a problem in Western Canada.
Huh.
That especially the durum
From
wheat.
the soil? Or...
Yeah, straight from the soil.
Ah.
So some of our durum wheat is unfit for North American consumption. It's only good for foreign aid. Serious?
They can have cadmium poisoning.
Yeah, but the thing is, if you have no food,
Yeah.
wouldn't you rather have
Better than
something
dying
that,
from that. Substandard. How can we stop?
because it's finished.
Oh.
See, it automatically retracts.
So then,
Well, that's because I ran it for 15 at
oh, right,
15%.
higher speed, that's why.
Yeah.
Huh.
always find that these are the hardest to take pictures of because it's through the glass. one was 15% feed rate. Console coal powder at 100% feed rate.